That's what I felt when I visited Tara Ashram, and there were lots of deaf kids, and they were trying to communicate with me with their Indian Sign Language. But I felt so bad that I wasn't able to understand them. So that's why we proposed a solution for that. Indian Sign Language to text and speech translator for the deaf community. And our vision is to be the bridge between deaf community and the non-signers.
Imagine a world where communication barriers between the hearing and the deaf communities no longer exist. Welcome to our innovative solution, an Indian Sign Language ISL to text and speech platform that bridges this gap using advanced AI and deep learning. Our website allows ISL users to communicate effortlessly with non-signers by converting hand gestures into text and spoken words in multiple Indian languages. In this video, we will take you through the core features, use cases, and the cutting-edge technology that powers our solution.
Let's dive into the technological workflow of our project. First one is website functionality. User will access our platform via an intuitive website designed to be user-friendly and accessible on the mobile laptops. The process flow diagram illustrates the steps involved in converting gestures into speech or text using an API. Here is a breakdown of the process. The first one is gesture input. A user performs a gesture using their hands or body. The gesture is captured by the user interface such as camera or other sensors. Then next step is gesture to speech and text. The captured gesture data is sent to a server where it is processed and converted into a speech or text. The converted speech or text then it is sent to an API for further processing or integration with the other applications. The API processes the speech or text and sends the result back to the client, for an example mobile app or website. The final output, which could be spoken words, text, or any other forms of media, is presented to the user. Then the next part is feedback. The user may provide feedback on the output, which can be used to improve the accuracy and effectiveness of the gesture recognition conversion process. Overall, the process flow diagram shows how gesture-based input can be transformed into a more usable output through the use of a server, API, and client components. Let's move to the next part. So this is the model workflow diagram. Our platform's core technology revolves around multi-stage deep learning pipeline that captures, recognizes, and translates Indian Sign Language gestures into text and speech. Let's break down each component. First one is the gesture detection using YOLO. The first step is gesture detection, where we use YOLO, a state-of-art object detection model. YOLO is highly effective and runs in real time, making it ideal for identifying hands and key landmarks in the video streams. It captures every detail such as the shape, orientation, and the position of each hand, allowing the system to detect single and double-handed gestures accurately. The second is hand landmark extraction with media pipe. Once YOLO detects the hands, we use MediaPipe, a Google framework specialized in extracting hand landmarks. MediaPipe pinpoints critical joints of the hand, such as knuckles and fingertips, which are essential for recognizing each unique Indian Sign Language sign. This data is then fed into the recognition model for further processing. Now the third step is gesture recognition with vision transformers and CNN models. For gesture recognition, we leverage an ensemble of deep learning models, including vision transformer (VITs) and convolutional neural networks (CNNs) like EfficientNet and ResNet. These models work together in a majority voting mechanism, ensuring that each Indian Sign Language sign is recognized accurately. Even in the complex scenarios like two-handed signs, VITs means vision transformers are particularly good at understanding spatial relationship, enhancing recognition of intricate gestures. Now the next step is the generation using NLP. Once gesture is recognized, it's translated into raw text using natural language processing. However, translating gesture directly to the text can often result in fragmented sentence that lack coherence. So the next step is contextual sentence using generative AI, Gen AI. This is where the generative AI comes into play. We utilize advanced Gen AI models such as GPT to refine and structure the text into meaningful, contextually inappropriate sentences. The Gen AI model adds nonsense, nonsense, corrects grammar, and forms coherent phrases that mirror natural human conversation. This makes the output much more relatable and accurate, ensuring that the communication feels authentic. After model interference, uh, after model interference, once the gesture is recognized, generative AI can convert them into coherent sentence. For an example, individual signs for "I am" and "hungry" can be transformed into the sentence "I am hungry," making communication smoother and more natural. And the next part is speech generation with emotional context. Generative AI can add emotional nuance to the speech output, such as happy, sad, questioning tones. For instance, if the gesture implies question like "Where are you?", the speech can reflect questioning tone like "Where are you?", enhancing the communication experience. So the step six is integrating speech synthesis APIs for the TTS conversation. The refined sentence are then converted into the speech using speech synthesis API like Google's TTS, producing clear, natural sounding audio output in the chosen Indian language. This step brings the text to life, making the conversation seamless. Now, the seventh step is real-time feedback loop for and user adaptation. Our system also includes a feedback loop that continuously adapts the user input, enhancing the model's accuracy over the time. User feedback helps fine-tune the system, ensuring that it remains responsive to new gestures and sign language variants.
Our ISL to text platform has many practical applications. Its key features include real time gesture recognition, instant text translation, and speech synthesis in various languages. Daily communication, education, healthcare, and public services are the few use cases. Daily communication. In everyday scenarios, family and friends can chat more smoothly. The platform enhances social interaction by translating ISL to text or speech instantly. Education. In classrooms, our tool helps teachers communicate with deaf students. It translates their signs into spoken words, encouraging inclusive education. This ensures students understand lessons without delay. Healthcare. In medical consultations, deaf patients can express their symptoms. Our platform translates their signs instantly, improving patient care and ensuring better communication with doctor. Public services. In government offices, deaf individuals can access services without barriers. The platform helps by translating ISL into text, making sure they get the information they need. Visit our website today and experience seamless ISL to text and speech translation. Together, we can change the way the world communicates.